Hi everyone, let's have a review about chapter 3. So on our course website, you can see this final exam review sheet. When you click that, you can see the review sheets of all the semester. Okay, and also if you go down and you can see our practice exam and the solution. Try to work on that. And remember, section 3.10, the application problems on related rates is very challenging. So I really hope that you can. So here are more exercises from your textbook. Okay, and so I hope you can work on these problems. The solution of section 3.10 is also here. So actually you can have the solution. So work on those problems first and then check out the solution. Okay, and here are some extra exercise from your textbook. And I also provide you the link to download the textbook. So especially for those of you who are not at school, so you can download it from this web. Okay. And so here are the exercise for chapter 3. The green color problems are the true or false questions. So please try to do those problems after you finish your homework. Okay, so more exercise are great. Okay, so let's start the review. Okay, so this is actually the whole semester. Okay, so let's look at chapter 3. So chapter 3, we talk about derivatives. Okay, what are the definition of derivatives? Okay, the f prime of x is the limit h goes to 0. F of x plus h minus f of x over h. So this is the definition. Okay. Oops. All right. Okay, let me erase that. All right. Okay. And let me choose a color. Okay. Yes. So this is the definition of derivative. And then what is the definition of the derivative evaluated at 1 point? Actually, we have two formula for that, this one and this one. And I suggest you to use this one because this one is very similar to the one with the definition of derivatives in general. So that's why it's better to use that one. Okay, and we also have a theorem. A function is differentiable implies it's continuous. Okay? The contrapositive is also true. If the function is not continuous, then it is not differentiable. Okay? So there are 3 types of non-differentiability. First type, when we have a corner, okay? Like that. Second type, when we have a discontinuity. For example, this is a removable discontinuity. This is a jump discontinuity. This is a infinite discontinuity. We also have the essential discontinuity. Remember? Okay, and the third type is when we have a vertical tangent. So you can see the slope here is undefined. So we have a vertical tangent. Okay, and after we find the derivative, maybe you have some like questions will ask you like to find the tangent line equation. Okay, so the slope is the derivative evaluated at that point, and then you also need to find the points. So usually the x values is given. If the y value is not given, you can put the x into the function f to find the y value. And then with the points and with the slope, you can use the point slope form to write the line equation. Okay, so and then we have the differentiation rules. We have product rule, we have quotient rule, and we have chain rule. Okay, and all right, and then in section 3.4, we talk about the trig limits. And remember that limit x goes to 0 of sine x over x is 1. And be careful, it's only true when x goes to 0. When x goes to infinity, this guy, the top is bounded by 1, the bottom goes to infinity, that's why the limit is 0. Okay, so when we solve the trig limits problems, the first step is you split the factor. Okay, so you split the factor, and then you're gonna group them or match them, right? For sine 5x, you want to match a 5x here. So when you divide it by 5x, you also need to multiply by 5x. And this is sine 3x, you need to match a 3x there. And when you multiply by 3x, you also need to divide it by 3x. When you see cosine of 0 is 1. So if you see cosine by itself, it's okay. You don't need to match anything for it. Just put 1 on the top of it or at the bottom of it. Okay. And then the slope of the tangent at A is the derivative evaluated at A. And then the slope of a normal line at A is the negative reciprocal. Okay, it's negative reciprocal. All right. Implicit differentiation, okay, 3.7. So here are the steps. You take the derivative on both sides. And then probably in the steps there will be some chain rule and product rule involved. Okay? And after you're done, move the terms with dy dx on the left hand side, and then keep the terms without dy dx on the right hand side. Okay, so in this step, sometimes maybe you have a term, half of it has like dy dx, half of it has no dy dx. So what you should do is you want to distribute it so that you're able to split. And then you can move the terms with dy dx on the left, and then keep the terms with dy dx on the right. Okay. Then you can factor out dy dx on the left hand side and solve for it. So usually you have something times y prime equals some other thing. So that's why both sides divided by that, you can solve for y. Okay. And 3.8, we talk about the logarithmic differentiation. So I hope that you can memorize all the derivative formula. Okay, so now please close your eyes. Okay, and what is the derivative of x to the n? That is n times x to the n minus 1. Next, what is the derivative of e to the kx? Well, that is k times e to the kx. And then how about the derivative of 6 trig functions? Derivative of sine is cosine. Derivative of cosine is minus sine. Derivative of tangent is secant square. Derivative of cotangent is minus cosecant square. Derivative of secant is secant tangent. Derivative of cosecant is negative cosecant, cotangent. And then how about the derivative of b to the x? Remember, father looks like the sun and the father has a fancy mustache. Okay, so that is b to the x. What is the fancy mustache? ln of b. So the derivative of b to the x is b to the x times ln of b. Derivative of ln of x, okay, the logarithmic function is 1 over x. Derivative of log b of x is what? 1 over x, and then in the denominator, you also have ln of b. I hope you can memorize all of these formulas, okay? So logarithmic differentiation. So there are 2 kinds of functions where we use logarithmic differentiation. The first type is when you see x is in the base and in the exponent. Okay, so here are the 4 steps. First, you let, I call it 4 steps in the notes, okay? First, you let y be x to the x, and then you apply ln on both sides. Then you also bring, so that you can bring the exponent down in front. So now you have a product. You're able to differentiate products because we have product rule. And then next, implicit differentiation. On the left-hand side, when you take the derivative of natural log of y, you get 1 over y prime. And on the right-hand side, you always have product rule, but then you might have chain rule as well. So be careful with that. And after you're done, how do you solve a y prime? Both sides multiply by y, but what is y? Look at our original function, that is y. Okay, so that those are the 4 steps. And then the second type is when we have a complicated quotient, like this example, right? And you use the property of natural log. When the factor is in the numerator, you add it. When the factor is in the denominator, you subtract. And you can put the exponent down in front. That's why you have 1/2 here, 1/3 here, and the 5 here. Okay? And then you can do implicit differentiation on the right-hand side because you have a lot of ln. So derivative of ln of u is 1 over u times u prime. So don't forget the u prime, okay? You don't put u prime in the denominator. After you get 1 over u times u prime, you actually multiply by u prime at the end. Okay, and then you can solve a y prime. That is the right-hand side times y. Y is our original function, so copy it down here. Okay, next we have the related rates. Yeah, related rates is very challenging because a different story involves a different formula, and that's why I give you many examples to practice. Okay? All right, so what are the steps? We first sketched pictures, name the variables. So we want to see what is changing. If it's changing, give it x, y, or A for area, V for volume. And what is constant? Give it the number. Okay? For example, if I want to draw an example here. So if we have a letter that slides down, okay? What is changing? Well, the horizontal distance is changing, so let's call it x. The vertical distance is also changing, let's call it y. Okay, how about the letter? Will the letter change? Will the length of the letter change? No, that's constant. If that is 10 feet, then just put the number 10 there. Don't name it as a variable. Okay, because then you see this is a right angle triangle. So when you write it, you get x squared plus y squared is 10 squared. When you differentiate, you get t at 2x x prime plus 2y y prime. So x prime is dx dt, y prime is dy dt. And on the right hand side, it's constant, so the derivative is 0. But if you name it as a variable like z, then you get like z squared, you get 2z, z prime. But no, this is not changing. Actually, this 10 is a fixed. So that's why z prime is actually 0. Okay, so you don't need to name it as a variable. Okay. So yes, the next steps, we write relations and then we take the derivative with respect to time on both sides. After we differentiate, we substitute the values and solve. And then at the end, check whether the answer makes sense. So like in our letter example, you see because we're sliding down, your x is increasing. So dx dt should be positive because it's increasing. And your y is decreasing. So your dy dt should be negative. Okay, just keep those in mind. Okay, so that is 3.10. Alright, so don't forget to work on those exercises, especially the 3.10. And I know you have a lot of examples in your homework as well. So for some problems in 3.10, they are hard. So you don't need to like be able to solve the problem like by your own, but try to understand it. Okay, the problems in your exam is not like this hard. So number 13 is actually pretty hard. Okay, number 14 is not quite hard, so you should be able to solve it by your own, okay? And then for more examples here, so you can see 25 is also very hard. It took me a long time to do it, but please, you can try to understand it, okay? So here are more practice. And when you have questions, feel free to email me or ask me during the office hours, online office hours. All right, bye.